Okay. So welcome to this session. This is about white boxes for the BNG use case. So I really appreciated that you stayed because it's the last presentation for today. My name is Carsten Michel. I'm working for Deutsche Telekom as a senior network engineer. And I'm working especially for a project which is called Access 4.0. Maybe some of you have heard about that. And in the first part of the presentation, I will give you a very short introduction into Access 4.0 and what we've done so far. And then I will focus a little bit on the BNG, the Broadband Network Gateway, which is a part of this solution, and which implication that has on a potential white box switch. So it's a little bit different from the things you already heard from data center stuff the last few days. So there are special requirements for implementing that BNG, which has an impact on the design of the switch. So we came up with a design of our own. But as we are an operator and not a manufacturer, we were not able to build that. So we are very happy that Delta joined in and built a prototype for us based on our ideas. So it's really good to see coming ideas into life. And that's the reason why Winnie is a co-presenter. And she will jump in then and give some more details about the actual design of the switch. OK, so you want to introduce yourself? OK. OK, so very short overview. Access 4.0, we made a couple of announcements within the last 24 months, I guess, in various conferences, various communities. This is Deutsche Telekom's next generation Access project. And it's all about increasing our gigabit footprint in Germany in a very, very cost-efficient way. So the project was actually started not from engineering itself, but from cost department. So it is really driven by the idea to have a more cost-efficient solution to produce gigabit products for business and residential customers. Cost does not mean especially hardware costs, but the whole life cycle, so hardware, software, planning, test and validation, operation, the whole life cycle. So we're really looking within this project into making lean to operate cost-efficient gigabit network for our customers. OK, so Access 4.0 is based on principles from CORD. Some of you may have heard about CORD. That's AT&T initiative for central office re-architecture as a data center. And a couple of my colleagues really liked that idea and put that into a project within DT. So for the last 2 years approximately, we've done some investigation. As the name implies, it's a data center which we built in our central offices. In Germany, we have approximately 900 central offices where we connect our access devices like OLTs for GPON, also MSANs for DSL to these central offices on the one hand side, and on the other hand side, we have uplink connectivity to our IP core network. And at that point in the network, in our traditional setup, as we have it today, there's a BNG, a Broadband Network Gateway from a black box vendor. And we want to break that off and make this a small data center with a spine and a leaf fabric. And that's the hardware we are going to talk about. And besides this spine and leaf fabric, we have some x68 compute within this data center to make sure we have this SDN control plane and some management and some automation stuff and so on and so on and so on. In contrast to CORD, which uses an x68 compute for the termination of the subscriber traffic, like a virtual service edge or something like that, we found out that in our case, this is not very efficient, because when we transport traffic from the leaf switches to an x68 to terminate the traffic, we need a lot of these compute nodes, because we in Deutsche Telekom have, depending on our legacy products, a lot of requirements on QoS, especially hierarchical QoS. We have requirements for a huge amount of access lists, of counters of statistics, of IP fix, data sampling, and so on and so on. And if you put all these things together, then an x68 platform is not very efficient anymore. And it's also not very energy efficient anymore. So at that point in time, we decided to put the termination of our subscribers, which are mainly PPP subscribers, into the leaf switch itself. So we have still x68 for additional value-added services, but the termination of our traffic is going to happen on the leaf switches. Okay, so this is the main architecture we have. And again, scope of Access 4.0, I already mentioned that, is designed to cost mainly. We want to have a very open scenario. We want to avoid vendor lock-ins like we have that in the past, where we just have one single vendor providing a BNG, because you all know BNG stuff is very complicated, so it's difficult to have two vendors, because then you have to have two different engineering streams and so on and so on. So we want to have a very open setup with open source software as much as possible. It doesn't work in all places in the network. We want to have open hardware, and we want to have a very clean architecture. So to be able to put this into our existing network, we have to make sure that on the outbound interfaces, for example, to our management systems and provisioning systems, we look like our existing BNG, so that we do not have any, let's say, kind of migration. We call that the Las Vegas principle. So we have an architecture where we say everything that's needed for communication within the central office stays in the central office, so we don't expose that outside. So we have a lot of internal communication and very little external communication. And again, it's about automation, CapEx, avoiding vendor lock-ins, and so on and so on. So maybe not all of you are familiar with the BNG. As I said, we're trying to replace the BNG, but we still need this functionality. So I want to spend a few words on what a BNG is for all of those not familiar with operator networks. So basically, it's the first IP device you see as a customer. So it's the device where a customer, which is aggregated in kind of DSL or GPON network, is connected to. And actually, the customer in our case sends a IP packet, which is encapsulated into PPP, into PPPoE, and then into a double-tagged VLAN stack. So the inner tag is usually provided by the CPE device, and the outer tag by the aggregation device, being OLT or Amazon, where we encode more or less the port number of this access device. And you see, in contrast to, for example, a normal data center switch, because I already mentioned we want to put this functionality on a leaf switch, there needs to be a lot more packet manipulation than, let's say, in a classical data center where you only have IP or maybe just single stacked VLANs or something like that. So you have to remove the PPP header, you need to remove the PPUE header, you need to remove this double-tagged VLANs. You also have to make sure that PPP keep alives are still sent and received, and so on and so on. And on the other hand, as I said, it's the first IP device in the network. It takes part in the core routing, so it's connected to the IP core network. So in the upstream side, we encapsulate the IP packet then into MPLS, maybe double-tagged MPLS if it's a business customer using VPN services, and then a simple Ethernet header in front of that. That's what happened on the data plane. On the control plane, which might be exposed on x68 servers, but some of that has also has to run on the switch itself. We need to make sure that we detect the first PPP frames for authentication. We need to do accounting on these boxes for packets in out, bytes in out for the customer. We run different services. A customer at Deutsche Telekom can have up to 12 different services on his DSL or GPON or whatever line. So we need to account for these services as well. And we have to make sure that we have access control lists on a per user or per customer basis. So for residential customer, it's pretty easy because it's a very simple template. But for a business customer, that can be increasingly complex. So we need to make sure that we have the functionality to do some kind of packet filtering as well. And that's a lot more than a traditional data center switch does. So putting that into requirements, we need to do double-tagged VLAN termination. We need to do PPPoE session termination, including all this control plane stuff like LCP, IPCP, IPv6CP. We need to do AAA towards the radius, or maybe in the future a diameter server. We need to do IP address management, which is control plane function only. Okay, so it's maybe offloaded. We need to do a lot of packet filtering, as I mentioned. We need to do hierarchical QoS. That's the hardest part from an ASIC point of view. We also need to do multicast replication. That's what I've not mentioned. We still have IPTV services based on multicast in Germany. For wholesale, we also need to do layer 2 transfer protocol termination, and of course, we need to do a lot of statistics. So nevertheless, we think that the OCP has done a lot of really useful work by defining switches, but the existing switch specification are not sufficient for what we want to do. So that's the reason why we were proposing new switches based on the requirements we have. Okay, so here are our core beliefs and drivers. So we want to have a spine and a leaf switch with potentially the same ASIC, although we are driven mainly by the leaf switch because this is a lot more complex from the data plane point of view. But we do not want to maintain two different hardware, so we want to have more or less the same ASIC, or at least the same ASIC family, so that we can reuse the SDK. But as I said, it's mainly driven by the leaf switch. Then we want to have standardization regarding the chassis, so we don't want to stock too many different parts, so not different form factors in field replaceable units and so on and so on. We came up with a 2-rack unit chassis, which is maybe slightly strange because most data center switches have 1-rack unit, but it's mainly driven by the port density we need for the leaf switch. And then again, as we want to share components, we decided to take that for the spine switch as well. We came up with a modular CPU board design. So we have right now chosen a special Intel x68 Broadwell CPU for purposes, but maybe someone else needs a bigger or maybe a lower CPU. So the board is modular. For instance, at some point in time, we decided we thought about having a bigger CPU to include IPsec encryption as well. We've not done that right now, but maybe that's the reason why it's interesting to have a modular CPU board to get a little bit more expensive CPU which can do more functionality. Yeah, and everything at a very compact design, power efficient, and so on. I mean, yeah, you have heard a lot of talks this week about energy efficiency and cooling, and yeah, I mean, that's also on our agenda, definitely. Okay, so let's put these requirements into switch ideas. So here you see 2 new boxes. The lower one is the leaf switch, the upper one is the spine switch. These switches are both based on Chromium 2C ASICs. That's the one which we think is the most suitable for our use case because it can perform HQoS on the traffic manager. It has deep buffers. It is very scalable from the number of ports, and the SDK provides more or less the functions we need. As a CPU, we're using a Broadwell D1500 series CPU. As I mentioned, at some point in time, we thought about using the D1600 because that one has QAT support, which allows you to do IPsec natively. But then we thought that we don't need that on the box and went back to the D1500. The box has, for our purposes, enough on-chip buffer to do the packet forwarding in the way we need that. Nevertheless, there's options to include an external TCAM or statistic chip. We use that on the leaf switch, not on the spine switch. On the spine switch, we think we don't need that, but on the leaf switch, we do. Actually, there are two different devices which are pin-to-pin compatible. The KBP, which can do table extensions, ACL, statistics, and so on. And there's also the TAP, which is similar but can only do statistics. So it's a cheaper device. We have huge requirements for statistics in our networks. That's legacy stuff we can't get rid of. So our customers can have up to 100 different counters we need to provide. And that's the reason why the COMAM2C as a standalone ASIC is not sufficient for us. So for the statistics counting, we use this TAP device as well. So we use the TAP, not the KBP, because we think the routing table is big enough for us. And last but not least, we have included synchronous Ethernet on 5088 because in the future we also have plans to terminate mobile traffic on these devices. So we need to provide synchronous Ethernet. We use here these 4 ports for SyncE input. For instance, so as I said, this is the leaf switch. In addition to the ports for SyncE and connecting some other stuff, we have 48 ports which can run at 10 or 25G. So you can configure that by software. That's for connecting our OLTs, MSANs, whatever devices. And we have 5 100G uplinks to connect towards the spine switches. Okay, and the leaf switch on top of it is just pure aggregation for the leaf switches. So it has 22 100 gig ports and 4 400 gig ports in the middle. That's those. And again, it has input for synchronous Ethernet and output for measurement for takt and for time and frequency measurement. And yeah, both of these devices, I forgot to mention that, have here Ethernet management console and USB port. Okay, so by the way, if you go by Delta's booth, then you can touch these boxes or have a look inside. So prototypes are available at their booth. And maybe I mentioned one thing is the COMAM2C is not available right now. So these prototypes are done with the Jericho 2C right now. It's also pin-to-pin compatible ASIC, but it has fabric interfaces, which we do not need. So that's the reason why we use it as a prototype to get early hands-on. But in the long term, we want to go to the COMAM2C.
Is it the white box?
Yes. Sorry? The magenta box. It's magenta. By the way, this specific RGB code of magenta is registered, right? It's a company color. So yeah, this is more, let's say, for marketing and showcase. I mean, in the end, even we won't install magenta boxes in our CEOs.
Without paint.
Whatever, black or gray or whatever. Okay, so you want to take over for the...
Okay.
Step out of this.
Hello, this is Winnie from Delta Taiwan. Thank you. So, yeah, that's another pink. No, I have this one. That's fine. It's whatever color you want, we can do that. So not only the white or pink. Okay, so here is a, oh, sorry. Oh, sorry. It's a Chrome 2C right now. The Chrome 2C, we have the total 96 length of the NRG 25G. So we're using 48 to, oh, sorry. Oh, this is okay, sorry, it's go too fast. Okay, here. So we're using the 48 length to have the SP28. It can support 10G and 25G. And the 4 length to have 4-port SP Plus to support 1G and 10G. And the other 40G, 40 length, we to support 10-port QSP28 that you can support 100 gig. And the rest 4 NRG is here connect to the CPU to be the 10G. So we use out of the 25G, but we did not use in the PAM4. But PAM4 is here, so we have the KBP or TAP, depends on your application, or because the cost wise is many different. The KBP can support TCAM and the statistical. If you just need a statistical, you can just populate the TAP. We also support the BMC. It's using, I think everyone using the ST2520. And here is the time sync here. Okay, so next one. Here is the bus you can see in our booth. So here did a big heat sink for the Q2C, and here the TCAM. Here the CPU board, and we have the air buffer on the 2 sides to make sure the power supply and also the whole system can have the enough airflow. And okay, next one. For is it here is the spine. The spine and the the design is much similar. So only the port configuration is different. So we using all the 25G to convert 22 port 100 gig. And of course, we still keep another 4 lane for 10G and the 4 lane to the CPU. And the other, all the PAM4 is for support 4 port QSP, so to support 400 gig. Other portion is exactly same for these 2 bus. So here's a look and feel on the top button. You can see here the black one is the air buffer. Because we put the 400 gig in the middle, I think everyone knows 400 gig is kind of the 15 watts, so you need a lot of the airflow. So we design this kind of air buffer to make sure there's a lot of airflow goes through the 400 gig. But Q2C is here, then the big heat sink will block the airflow. So this heat sink design on spine and the D is different. In here, the heat sink is kind of the, how to say, in the middle side, there's the empty, no fin. So the airflow can go through and very direct and the very high airflow to display the heat on the QSP 28 DD. Yeah. And all of our design, we reserve the slide rate. So this is a 2RU design. And the dip is around 48 centimeter. So it's quite heavy because of 2 power and the fan in the back. So all the design, we will have the slide rate. Next one is our CPU module. All the CPUs in module. So 2 DIMM and 2 different kind of the SSD to support different requirement. And we have 2 flash to provide the BIOS, and there's the backup one. So anyone is fair, it still can run it. The whole board is all interface connect to the main board, and also have the thermal sensor on the board and the power monitor here. Okay, I think Carsten, you can do that. Okay. Okay, here is the look and feel. I think many people already go to our booth. You already see that. So the design concept is we want to build no matter fan or power supply is exactly the same. So for the user, it's easy to just maintain one path for two model, and yeah. So we're using the 80 centimeter fan. You can reduce the fan noise. Yeah.
And the power consumption.
Yes. good point. Thank you. And we also plan to do the compliance here, but yeah, it's in progress. Yeah.
It's a very small question. What wattage do we need for the power supplies?
Actually, Delta is the power supply supplier. So whatever so far we may say we reserve 1300, but if we have the real unit after the test, we can replace to the, for example, 800, 850. We have the different range of the power supply. But the first sample for safe, we may use in 1300. Yeah. Okay.
Depends on what 400 gig optics you want, right?
Yep. Okay.
Okay, thanks, Winnie. I want to just go back a couple of slides and want to add one additional point in the design which I've forgotten to mention, and that is except the PCIe connectivity between the Broadcom ASIC and the CPU, which Winnie mentioned, we've also introduced 10G interfaces from the PM25 interface of the Broadcom, so SerDes links to the CPU. So there are 4 connections provided here, but only 2 are used by the CPU. And the reason for that is that if you do PPP termination, or if you do subscriber termination in general, then you have to watch out for instance, keep alive packets, so to keep the PPP session alive, that's one thing. And the other thing is you have to watch out for fragmentation, which you usually do not see that much in data centers. And the point is that both of that the Broadcom ASIC cannot handle natively. The Broadcom ASIC can just do packet forwarding based on a very complex rule set you provide, so you can program the forwarding pipeline, but you cannot react to certain things, like, for instance, fragmentation. And therefore, we have this additional channel so that we are able to forward packets which need fragmentation to the CPU, so that the CPU can decide what to do with the packet and then send it back to the Broadcom ASIC for forwarding. So just one additional note I wanted to make.
How to DDoS it?
Potentially, yes, but okay, then you have to come up with filters or something like that, rate limiter, and so on. But we did some measurement on our existing BNG platform on how many packets per second need to be fragmented, and we came up that in that case the PCIe bus would not be sufficient anymore. Okay, so just as a side note. Okay, so then let's come back to the last slide. So basically, this is our proposal, and Delta was nice enough to provide a prototype so that we hopefully get that within the next 4 weeks so that we can see if the SDK also works. But in general, we want to propose that as an OCP specification, and we are really seeking feedback from the community if this is a design others might want to use as well, or if there are modifications needed so that others can use that. So again, we are interested in open hardware, also in open software, which makes more sense if a lot of people are interested into. And in addition, as I mentioned a couple of times, we're also seeking in lower costs, which means that also better if a lot of people are interested in that. So if you have any feedbacks, if you have any comments, if you have interest in joining this specification, then yeah, please let us know. Okay, then thanks for your attention.
Switch is running, SDK is running right now. From the Taiwan team, they just report to me. The SDK is running.
The SDK is?
Yeah. SDK is running. So the unit, the traffic can be running right now.
Ah, okay. Yeah.
Have you been thinking about something like Clips? Clips was from Redback, but it's Ethernet all the way, let's say.
Not sure. I personally not, but maybe someone else in the company.
For example, for voice, if it's voice over OMCI,
yeah.
I mean configured. So if it goes over IP host, then it uses DHCP to get IP address, and this can be treated also from BNG.
Right.
And for that purpose, you might need something like DHCP communication. So it's like Ethernet all the way still.
Yeah, but in our case, our subscribers don't get IP addresses via DHCP. They get them via radius, right?
Yeah, but okay. So we provide IP address to RG function, and RG function has the voice. If it uses voice, it's on the same IP address as RG.
I mean, yeah.
One IPv4, one IPv6 address space to the residential gateway.
Yes.
And the VoIP agent, the SIP agent, is living on this box and
Yes.
the same IP address.
Okay, so you don't configure.
No, we do not have two channels. We do not have two channels for voice and data. We have just one IP channel because we have a converged product.
Same virtual router and
Yes.
on the ONT.
Yeah.
Technical level, you can do it on the voice.
Yeah. But there is a lot of ONTs or devices who have it separated. For example, my company uses the HCP towards the
Yes.
subscribers, and it's
But-
quite popular.
But you do not use PPP.
For some.
Yeah. To be honest, we would like to do that as well, but we have a lot of legacy products in Germany, and especially we have the requirement for this wholesale. I mean, we have regulation, so we need to provide kind of wholesale, and it would be different. I mean, on our side it might be easy, but on the side of the other telcos it might be very difficult. I mean, it's something we are looking into actively, but at the moment we first have to migrate our legacy to the new platform and then think about how we can get rid of legacy.
Okay, and how about
So
the source code? Will it be published?
The source code for, okay, I've only talked about the hardware today, so
Hardware is just hardware, you know.
right. For software I mean, this decision is not made yet. Our prototype is based on a commercial software version, so it's not open source because for the timelines we have and for what we've seen so far, that's our first choice. But it might change in the future. So,
Okay.
and so we are not a software development company, right? So we are an operator. So. If we come up with a solution which can be open, then very open, that's fine. But right now our prototypes is based on also commercial software. Yeah.
Okay.
Yeah.
BMC, is it open BMC? And is the firmware or the BIOS, is it open firmware or?
No. BMC. Sorry. What for BNG? Too many abbreviation. Open BMC. Yeah, Paul can maybe jump in here.
I hope they are supplied. We don't have it yet.
Yeah, so far we may using AMI BMC, so it's another open one. But but our team, the software team, is work on the open BMC at the same time. So yeah,
Same question for the BIOS.
BIOS
Is it open firmware from OCP or?
we using the same AMI BIOS.
At this moment.
Yeah.
You expect that we come to the open BIOS and the open BMC because we heard the announcement yesterday that is to be mandatory in 2 years from now, right?
Oh really? Okay, then I bring back to
It's an interesting question. It was not clear if it's to apply to only to computers, only to x86 servers, or if this is generalized to all OCP
No,
devices.
it's generalized
It's not
for
clear.
everything.
Generalized?
Yes.
Okay, so the question is completely, will we be there in 2 years?
okay, I bring back to our software leader to ask it.
From the switching point of view, it's just important that it runs ONI, right?
Yeah. Yes.
So my understanding is the current BMC, why we can't use the open BMC yet, there is some gap, right?
Yes.
Sure that
Yes.
some exists. So I think that as a community, we have to try to make sure that those gaps are closed, right? And not that we have a particular preference that we want to use a commercial BMC, but we don't want to hold up your, development and deployment because things are not there, and there does not seem to be. So I think that for all of us, the community, rally, and, please help push that so that we can adopt the
Yeah.
open BMC.
Yeah.
You'll notice that there's no one from AST Speed that attended OCP.
the spine nodes on your network, can you use XGS boxes instead of a DNX for the spine node, just for the spine?
Potentially, yes. I mean, the requirements for the spine are a lot lower than for the leaf switch, right? We do not need access lists. We do not need QoS in that. The primary reason why we used also the Broadcom CommTC here is because we do not want to have two streams of software development and testing and so on and so on. We wanted to reuse the ASIC. But basically, your question is right. You could use a much simpler ASIC here, if you want to. But then you have additional maybe testing and certification and development costs. I mean, you have to look if you spend this on hardware or on the other processes in your company.
If there's a lot of open source nodes, you can actually do the XGS.
Yeah, sure. But within Deutsche Telekom, we have a very long and difficult process of getting hardware and software qualified for our production network. So you have to think about giving a little bit more money for the hardware, but then have only one process of qualification, or getting a little bit cheaper box and then having two streams. So this is some decision, which is not finally made, but right now we are looking into having the same ASIC.
The answer to that is yes, you could. You look at your own deployment and your development situation. Like I completely agree with you, and I can completely echo what you said. So you have to look at that. Like, do I now have to inventory two different boxes?
Yeah.
And I have to now maintain two different software, and possibly deal with two different software suppliers as well.
Yeah.
Carsten, I have a question. Can you go back to the slide, your last slide about hardware consideration? I thought I had a question.
This one?
No. Yeah.
To the leaf switch?
No. The title is hardware consideration. Here.
Yeah.
So I have a question here on this, right? Do you have any requirement in terms of installing the TPM chip, like for trusted platform module, or that is not a requirement? Have you guys considered that? Just in general, when you build the hardware, TPM chip.
Yeah, this include in the CPU module already.
Okay.
Yeah, we do.
Okay.
We do
Yeah.
have. Yeah.
Okay.
Yeah.
So you do. So now, do you plan to use them, like enable them, and you plan to manage them, like with, the certificate and stuff, or do you have plan to use it? I mean, you can have it, but you can leave it disabled, or you plan to
Which chip is that?
the TPM, trusted platform module.
And
Oh.
secure boot, something like that?
We have internal discussions about secure boot and TPM,
Yeah.
and for the moment we are not sure that this extra complexity will be required for us. So if we can avoid this complexity, maybe we'll leave it disabled.
Okay.
Okay. More questions? Yeah.
Is this the control plane board? Is that a more custom format, or is it just a normal ComExpress module? And if so, what was the driver for using it?
The control plane software?
The,
So
the control plane board itself.
CPU board.
Is the physical form factor a normal ComExpress, or was it like
Oh.
a more custom?
that goes to you, the CPU board.
The control plane board, right? The CPU board. Is it a normal ComExpress format, or is it like a
Oh.
custom thing?
No, there's a custom thing. That
So what was the driver for that?
it's we do that is some of the consideration, because if you will come in you still need a big connector, and in the when you do the
Gigs, right?
not only that, some of also consider the 10G also consider the when you design the chassis, then how to connect the board to the main board. Yeah, our design is we can do the two-way. If we have the very limited the height, yeah, we can do the coplanar to connect the main board and the CPU board. But if we did, for example, for this, it's a 2RU, so the space is not an issue. So we can do the top to down, then we to show the chassis tips. Yes. Thank you.
Also, you
in the CPU.
From
Yeah.
the CPU to the Broadcom ASIC.
Yeah.
How much?
Yeah. Com Express did not have that. Yeah. Oh, yeah. Because here is the D1500, but we can change it to 1600. Then we can connect 4 10G. Yeah. So we reserve that, but so far,
Yeah.
yeah,
Right.
yeah.
The reason is the D1500 only supports 2 10G, while the D1600 supports 4 10Gs. And if we would go for the D1600, we would need the 4 because then the driver would be to have IPsec encryption, right? So you need additional bandwidth. But from the ASIC, we just take one of these 25G SerDes quads, and all of those 4 links are provided on the board.
So
Yeah.
the PCI Express will be just a pure control plane for the ASIC.
Yeah.
No package.
No. Yeah.
For the two storage, why do you use different storage?
Storage.
It's the same. You mean the SSD or the flash?
No,
Oh, SSD two different is because the size. If you some of the customers, some of the application, they may so far we support 128 gigabyte, but some of the customers they may need 1 terabit. Then for the top one, it's not available because it's small, so only can support from the bottom one. But if you just using the bottom one, then the size is bigger. So in general, you can just using the top one. It's smaller. So it would, yeah. So yeah. It depends on you. You can have 2. You can have just 1. Yeah.
The guy in the back says that we're running out of time, so we can do that offline. So thanks for your attention.
Thank you for your. Thank you.